Hi, my name is Mohammad Ashikul Islam Sajid. I'm from Group 9 and BF of Group 9. And first of all, our project name is brain tumor segment. And first of all, we can see that we use NumPy and Bible, and we also use sklearn and preposition. We also use split folder to train our dataset. So second of all, we also used TensorFlow, and this is for our virtual memory. So now this is our dataset, and this is the dataset we have used in this project, and it's from Bratz 2023 training data. All of the dataset are MRI images, so we will train those images, and we will try to get better output from this MRI images of brain tumor. So now we can see that this is test image flare, which will segmentize our dataset, our MRI images, and this is the same as this, and this is our one of our dataset, and this is another dataset. And this segment we are working on our dataset, and we are actually imaging a mask, and we also try to segmentize our brain tumor picture, and the mask might label which voxel 3D pixel corresponded to tumor tissue and which is do not. And for the shape of the mask refers to its dimension, which are typically represent as a tuple tuple containing the number of elements along each axis. In a 3D medical image, the shape usually corresponded to height, width, depth, z, y, x. So this is from now for the slicing and slicing. So instead of feeding individual slices to the machine learning, we know that in slicing approaches involves staking multiple consecutive slices along with the z-axis to create a 3D volume. For the 3D volume, we are using n slicing. So we can this is the plot. Okay, plot dot subplot. So this is our image flare. This is image T1. This is image T1C, and this is image 2 and mask. So for the comment part, we also use np.stake, and we are using text, image flare, test image T1 and test image T2 from these images. And for the slicing part, we are randomly slicing our brain tumor segments, MRI pictures, and that will give us a better output. If you can see, the image flare of the image T1C is this, and the image 2 of the mask is this picture. So now the test image 2 and the test mask. So the test mask is In medical imaging, a mask is a binary image that indicates the regions of interest or specific structure within the image. For instance, in the context of brain tumor segment, the mask might label which voxel 3D pixel corresponded to tumor tissues and which do not. So this is what we're doing. We will find out which has tumor issue as which do not, and if anyone have any segment have any tumor issues, we will find out that and we will segmentize them. Okay, now for the test mask we are using nib.load. So it is actually writing our data set. So this is our data set, one of our data set. So they are the same, and now we can see that in this segment we are scale our feed and the tame image tape image and the function and the feed and flare list. Okay, so if we look at this segment, we can see that so robust scalar and mean max scalar and standard scalar, we first need to import the appropriate scalar from the scalar preprocessing as we have shown before, and to initializing the scalar we have to initialize an instant scalar object. So this is what we have implanted here, and at the last of all this feed transform is a convenience method that both feeds the scalar to the data and transform the data in a single step. And in conclusion, we need to apply scaling. Okay. So if we can see that this import split folder, this is our input folder and this is our output folder, and split folder is actually we can split our input and output into a different segment. Okay, so for the image loader, we can see that image directory, image list, mask direction, mask list, and batch size, and this is the length of our image list, and the batch is the limit, and this is the tuple with our x and y axis. And we can see that this is our train image and train mask directory, and in here we will again using plot.subplot, which means we can see our plot graph. Okay, this is our mask we have got from our image T2, and this is the image flare of image T1C. So now this is the 3D model. We are using conf 3D for our 3D model, and this is the matrix, conversion matrix, and for the convolution layer we are using conf 3D. So there are max pooling also. We are using this for our 3D model. and we can see here this is the input one for our input layer, and this is the convolution layer 3D for this is the output shape, and we are using plot dot subplot plot dot I am sure for this output. And we also this is our, as I have told before, this is how we sort our train and image directory. So this is another graph plot. We can see that right here we are using plot dot subplot for giving us this output, and this is one of the MRI images from our data set. So as we have seen that there are plot and the taste imaging and taste maskup for this individual and subjective one. This is our graph we have gotten from our these images, how much tumor does actually exist. So in here we also use that the convolution layer 3D, and to segmentation the model we also use the what amount of segmentation we are really using in our dataset model. So that's here, and the input and output shape is already here. And these are our total RAMs of 5,06,044,828, and this is the trainable RAMs, and the non-trainable RAMs is 0. We can also see that right here. And now we can see the training and validation loss here. Okay, so this actually shows that how much is training accuracy and how much the validation accuracy. The red one is the validation accuracy and the right one is the training accuracy. So these are also another part of the training and validation. So we can see that validation mean IOU is less than the training mean IOU. So in this segment we are predicting our data result, our test images, our test mask, and we are using plot. Again we are using slice and plot to get the actual output from our testing and prediction images. You can see this right here. Okay, this is our testing image, this is our testing level, and this is the prediction or test image. Thank you.